Hi there, it's Chris here from Technify Networks. I'm making this video in order to walk you through the DHCP DORA process in a wireshark capture. Basically, we talked in one of my videos, we talk about DHCP, and that DHCP stands for Dynamic Host Configuration Protocol, which is a protocol that is used to dynamically assign IP addresses and other network parameters to network devices that are configured to use DHCP. And I also said that DHCP uses UDP port 67 for the server and UDP port 68 for the client. And we talked about the information configured through DHCP. Now, those information are IP address, subnet mask, default gateway, DNS, and other information that are needed for a device to communicate on the network. And so the DHCP DORA process simply stands for, the D stands for discover, and the O stands for offer, and the R stands for request, and the A stands for acknowledgement. And so basically, what happens is when a client boots up or he wants to join the network, he has to go through the DORA process in order to obtain an IP address. So we are simulating this as a client or PC and this as the DHCP server. When the client boots up, he sends, in order to obtain an IP address, he sends a DHCP discover message, which is a broadcast message to any DHCP server that is configured on the network will respond to that message. So if there is no DHCP server configured, then the client does not get an IP address. So, but we're going to simulate it as if here there is a DHCP server configured. So it sends a discover message and the DHCP server responds, and the discover message is a broadcast. The DHCP server will respond with offer, and the offer will contain the IP address which the DHCP server is offering this client. So, and this will be a unicast message. So that's a one-to-one message. And then the PC or the client will respond with a DHCP request message, actually requesting for the IP address that has been offered to it. And then the DHCP server will respond back to the DHCP client with a DHCP acknowledgement message. So, and every message that the client is going to send to the DHCP server during this DORA process will all be broadcast messages. So before we jump right into it, this is the topology we're going to be using. So I'm just going to show you something quickly. CMD, I'm going to go to my command prompt and then I'll say ipconfig /all. So that's my current IP address, IPv4 address and subnet mask. So what I will do next is to do ipconfig /release. That's in order to trigger the DORA process. But what I want to show you, then I do ipconfig /all. So right now, you can see the address I've got at the moment. I don't have a valid IPv4 address. I've got an APIPA address. The one that is highlighted here it starts with 169. So APIPA, that's APIPA, is actually, it stands for Automatic Private IP Addressing. It's a feature in operating systems that enables computers to automatically self-configure IP address and subnet mask when their DHCP server is unreachable. So because I've released my IP address and I've not renewed it, so that's why I've got that address. So at the moment, this computer cannot communicate with any other computer on the network as long as it's got 169. The IP address starts with 169. So that's APIPA. So I'm just going to renew that, then we're going to get into our wireshark capture. So I'm renewing it, waiting for the get. So I've got a valid IP address now. So that's about that. So I'm capturing this already in Wireshark. So what I'm gonna do is to trigger the DORA process. So because this uses a different kind of command, so I'm just gonna say IP DHCP. That's what's gonna trigger the DORA process on this PC here. Okay, so now I can go back to our Wireshark capture. So we've got, if I say show IP, so we've got a valid IP address from the DHCP server now. So, and we can see, so it sends the discover message twice. So this is what we need: the DORA process, discover, offer, request, and acknowledgement. And so we're gonna start with the discover message. So basically what we've got here, yeah, that's the discover. So what we've got here, that's the layer one. Yeah, that's the layer one frame. Yeah, so it's just saying the bits that has been transmitted on the network media there. So it says 3,248 bits. So in the form of zeros and ones. So then we've got the layer 2 Ethernet frame here. So this is the source IP address. I mean the source MAC address. So that will be the MAC address of the PC, and that's the destination MAC address, layer 2 MAC address, that's broadcast. So that's all FFFs, because the DHCP discover message is a broadcast message. So it's sending it to a broadcast layer 2 address. And then the internet protocol, that's the layer 3. So we can see that the source address is all zeros. And then the destination address is broadcast, layer 3 broadcast address. And then we can see the transport layer for the UDP protocol. We can see that the source port here is UDP port, user datagram protocol 68. That's from the client, because we say, yeah, the client uses UDP port 68, and then the server uses UDP port 67. That's the destination port 67. And then the DHCP data itself, the message, we can see the option 53 talks about the message type, which is discover. So then let's look at the host name. The host name, the person sending it, that's the PC, the name of the PC, Technify underscore ch1. And then the client identifier should be the MAC address. Yeah, so that's the MAC address. That's the client's MAC address. So that's about that for this. Yeah. So we look at the offer message. The offer, we can see now that it's got a source address and it's got a destination address. So the offer message is sent by the DHCP server. So this is the physical layers. So those are the bits that are transmitted onto the network medium here. So, and then the layer 2, we can see the source MAC address, and then we can see that's the MAC address of our DHCP server, and then the MAC address of our client, that's the destination MAC address. So, and then Ethernet Protocol version 4, this is a network layer, layer 3. So, and then we can see that the source IP address is the IP address of our DHCP server, and then the destination IP address is the IP address of our client. But basically, it's offering it's this IP address. So, and then the UDP, the transport layer, we can see the UDP protocol. The source port is 67. This time around, this message is coming from the DHCP server, and then destination port is 68 because it's going to the DHCP client. So the client uses UDP port 68. So we're just gonna open the the DHCP data itself. So, and we can see that the message type here, we can see it's offer, that's option 53. And then we've got option 54, DHCP server identifier, which is the IP address of our DHCP server. So if I open it, yeah, it's just the IP address. And now he's talking about the option 51, the IP address lease time. So he's offering it for a day, which is for 24 hours. So 86 86,400 seconds. That's for one day. So then the renewal time value, so that's 12 hours. The DHCP renewal. This renewal time value is when a client simply renews the DHCP lease time. The actual IP address and the MAC address in the server entry and any DHCP option used will all remain the same. And this is done during the half time of the lease, whenever the half time of the lease has passed. So the client will send a DHCP request message to the DHCP server, and this message will be a unicast message then. So the rebinding time value here, the rebinding time value here is actually when a host will remove all the network information it may have previously obtained from the DHCP server, and it will begin the whole process from the scratch. So whenever the host attempts to perform a DHCP renew, if it fails for some reason, it will attempt a rebind. So that's about that. So in 24 hours, it has to rebind itself to that DHCP server. So all this, yeah, that's just the IP address of the router, which is our DHCP server. It's the same IP address, and then the domain name. Let's see. Here, the domain name server, the DNS server is still the DHCP server, and then the domain name is what I use, technifynetworks.com. So that's about that. Then we go to the DHCP request. So this request is from the client, from the PC. So like we said before, everything that the client, all the messages that the client is going to send during this DORA process, it's all going to be broadcast. So we can see the source IP address is saying all zeros. And then the destination is 255.255. That's a layer 3 broadcast address. So we start with the Ethernet frame. So the Ethernet frame here will be the source MAC address is for our PC, our client, and then the destination now is the MAC address of the DHCP server. So, and then we've got a layer 3 IP, so the layer 3 packets. So the source the source IP address is all zeros, and the destination is all broadcast, layer 3 broadcast. So, and then we've got from the source port, that's the layer 4, the transport layer. We've got the UDP protocol. So the source port is UDP port 68 from the DHCP client, and the destination port is the UDP port 67 for the DHCP server. And then we've got the DHCP data here. So basically the client IP address in the data is saying the client IP address, that's the IP address that has been offered to the client. So we start from here. Basically, the DHCP message type is request. So, and then the DHCP server identifier is 10.1.1. That's the IP address of our DHCP server. And then this is the requested IP address. That's the 10.1.1.3. And then the client identifier, client identifier is the MAC address of the client of the PC. So And then the host name is the host name that I've pre-configured on the PC, technify_ch1. And then the parameter request list. So we've got the subnet mask, the router, the domain name server. Yeah. So yeah. So those are the things that has been requested, the parameter request list. Yeah. Yeah. So we're just gonna jump to the last message, which is the acknowledgement message. So we've got the Ethernet frame here. So which is the source MAC address this time around is the MAC address of the DHCP server, because the acknowledgement message is sent by the DHCP server, and the destination MAC address, layer 2 MAC address, that's the MAC address of our PC. And then the layer 3 internet protocol, we can see the source IP address is the IP address of our DHCP server, which is 10.1.1.1, and the destination IP address is the 10.1.1.3. So that's the address is offering to the DHCP client, to our client. And then we can see the layer 4, the transfer layer UDP protocol, the source port, UDP port is 67 from the DHCP server. And then the destination port is port 68, UDP port 68. So we're just going to look at the DHCP data itself. So the option 53 message type is acknowledgement message. And then the DHCP server identifier is the IP address of our DHCP server, 10.1.1.1. And then the IP address list time, we talked about that already, that is for 1 day. So that's option 51. And option 58 is the renewal time value. So it has to be renewed in after 12 hours. That's half of the term of the lease. So we talked about that already. And then the rebinding time value, that's 21 hours. That's when the DHCP client, the PC, will actually have to rebind itself with the DHCP server. And then this option 3 is the IP address of our router, which is the same as our DHCP server, because we are using a DHCP, we are using a router as our DHCP server here. So, and then the DNS is still the same IP address as our DHCP server, and then the domain name technifynetworks.com. So that's about that for this video. If you find this video helpful, give it thumbs up and don't forget to subscribe to our YouTube channel. Until next time, see you in our next video. Thanks. Bye.